Hey class, Colin here.
Nick too.
You know, when I heard about this project, I got pretty excited because the project was completely free reign and open to any subject, as long as it had to do with physics. But I bet a lot of you were thinking, I don't even know where to start. That sounds daunting. But where did we get the phrase, that sounds? I mean, someone is speaking to us, and technically, yes, that is a sound. But wouldn't a daunting sound more accurately be a scream or daunting music? And speaking of, how fast is sound? I mean, we probably all know that by counting after a lightning strike, we can tell that it's about a quarter mile away for every second. But how fast is that really?
How?
Well, according to gsu.edu, at 18 degrees Celsius, sound moves about 342.4 meters per second, or 767 miles an hour.
Hey, but that's pretty fast.
So when I'm talking in front of the camera, sound is pretty instantaneous. But what if I were farther away?
Right now, I'm standing about 30.5 meters away, and it's about 47 degrees Fahrenheit, which means you're actually hearing me about 0.085 seconds now.
That didn't really change how long it took the sound to get there, because I wasn't all that far away. But what about jets and planes overhead?
I got the answer. You know, every time we look up, we see a plane. And it's not quite where we thought it was, you know. It's usually in front of its own sound, because it's so far above us that the sound lags. So take, for example, a commercial flight flying at roughly, 30,000 feet. You know, it takes about 26 seconds to reach us, way down there. Trust me, I'm smart. I wear glasses.
Hey Nick, is that why planes change sound when they move overhead?
Actually, it's because of the Doppler effect. You know, an object making a sound, this one here, sound waves radiate out. An example of that would be, if you slap your hand in a pool, it makes waves. These waves are frequencies, Person here is hearing the frequencies, sound waves. What happens when sound is moving? We call that subsonic, moving slower than the speed of sound. Take, for example, the one on the right here. Now, when an object is here, an object made this sound right here, the outer ring. And as it progresses, movement, it makes more rings. If you look over here, wow, those sound waves are all bunched together. And that makes for chaos, versus on this side, where, it's a little more, less frequent. So it's a higher pitch in the front and lower in the back.
You know, Nick, that kind of gets me thinking. Jets, when they go by, say during an air show, have you ever noticed how they get really loud when they point at you?
Yeah.
I think that may have to do with the Doppler effect. Now, don't quote me, because I'm not a scientist, but when sounds are moving around, if it's not directly pointed at you, they may be spaced farther apart between the sound waves, but then when it's pointed directly at you, they're closer together. Generally, we would think of this as getting a higher pitch, but potentially that's why it's really loud when a jet's thrusters go right at you. And after that, we should enjoy a drink from our tasty beverages. Science. And how about in outer space? I mean, we only hear sound because it vibrates through a medium like air in our atmosphere, or water, or metal.
But isn't space a vacuum with no atmosphere? Do all the scientific movies have it wrong?
And would a TIE fighter really explode with no oxygen to burn?
Well, that's getting off topic. But space actually does have a very low atmospheric pressure.
It's mostly a hydrogen and helium plasma at a density of about 1 hydrogen atom per cubic meter at a temperature of 2.7 Kelvin.
So we can basically say, yes, space is a vacuum, and therefore sound cannot propagate.
Or at least to the human ear.
Touch the sound of silence and in the naked light I saw 10,000 people, maybe